Okay, one of the things we found with nutrients and with agriculture is we seem to be more and more regulated. I think we talked about that at the beginning of the semester when we were talking about government involvement in agriculture, less financial support, more regulation of agriculture. One of those areas that they're regulating us is in our nutrient and our manure management. And it's more specifically because of manure management, and the reason it's come about, people, is because we've had manure spills out there that have got into our stream waters and have killed fish, and the press from that gets laws made. Those laws have been made. We have to deal with them. One of the laws involves the WEPP index. Now, one of the things that causes fish kills, and we'll look at that a little bit here, is too much phosphorus in that water causing eutrophication. I talked about that with phosphorus and nitrogen. So everybody says, okay, let's just stop putting phosphorus on our land. Well, thing is, we know from our earlier discussion that phosphorus is pretty much fixed to that soil. It doesn't leach. Okay, so that doesn't mean necessarily it's going to end up in the groundwater, even if we've got, or surface water, doesn't mean groundwater at all. Doesn't mean it's going to end up in the surface water unless we get a lot of erosion. So wise people got together and said, you know what, we understand phosphorus can be an issue, but can we create an index to take into account all the different farming practices, including soil conservation, to come up with an index that even if they have high P, they could still be able to apply manure to some of that ground if they've managed their soil erosion. So that's what the WEPP index is. It's actually a way of dealing with regulation to still allow us to farm the way we want to farm. It's required for manure management plans and even nutrient management plans. Manure management plans, by the way, and that will be what we're getting into shortly, are required for any confinement feeding operations that are more than 500 animal units. And keep in mind, that goes back to that animal unit thing we use when creating pastures. I believe a dairy cow runs at a 1.4, so you're at 360 some dairy cows. Once you're over that, okay, you are now mandated to have a manure management plan and follow those laws. Nutrient management plans are something that's coming along too, and those actually will cover feedlots now, open feedlots, but now we're over 1,000 animal units, and we're not going to quite get into the discussion of that in our class here. We're more worried about manure management plans in the 500 animal units. So that'll come in a discussion later. Anyway, MMPs and NMPs both use the P index to determine application rates as far as maximum rates. Why focus on phosphorus? Well, most of Iowa waters are high in nutrients. I'm sorry, we raise crops in Iowa, we fertilize our fields, it's going to result in some ending up in the water. What is an acceptable amount? Problem is, P will stimulate algae growth. We talked about that. It causes turbid water. It causes algae blooms. That toxic algae bloom was going to cause low dissolved oxygen, and we're going to have more pollution tolerant fish in there versus the good fish. In other words, we're going to lose our trout and gain our carp. Okay, and I know a lot of you like to fish. Okay, you're losing your trout, gaining your carp. I'm not sure that's what a real fisherman wants. Okay, so we want to keep our waters clean and clear. N-based manure plans, which is typically what historically we've been on, is we put on as much manure as we need nitrogen. We'll tolerate that much manure. It tends to build up the phosphorus. We put on a whole lot more phosphorus than we need. I'll illustrate this in a minute. Very high soil tests will increase the risk of phosphorus getting into the water. So we need to assess that risk of phosphorus. Example, an open feedlot manure from Iowa State University, we're going to say in this case nitrogen, there's 22 pounds per ton in this feedlot and 16 pounds of P. I'm assuming this probably is beef cattle or similar. 40% of that N is available in that first year. The rest is either leached or evaporated or available in later years. Table there showing you how much is there. Let's put in charts. Charts tend to make more sense. On a 10-ton application, you're using that much, 60 out of 100, and leaving 130 pounds. In a 20-ton application, you're taking 60, leaving 260. In a 30-ton application, and there are some people putting 30 tons per acre on there, you're leaving 420 pounds. You can see how that pie gets pretty big of what's being left in that field every year with that application rate. If we put it on another chart, let's say we did this for 10 years in a row at that 30-ton application rate. That's that red line. It would mean if I stopped, just totally stopped putting manure on after 10 years, it would take me 75 years to get that phosphorus back down to where it was. 75 years. Now, There's another good reason, by the way, to soil test. What you will find on a farm that hasn't been soil tested and has had livestock, and all farms have had livestock, by the way, in the last 100 years, you will find they are fairly high in phosphorus because of that excess of manure, particularly near the buildings where most of the manure went. All right, so it's important that soil test in terms of that phosphorus. You could save yourself a whole lot of money in commercial fertilizer. Even if it hasn't had livestock there for the last 20 to 30 years, you will probably still find high phosphorus soils out there. Okay, that's the reason for our index, particularly with our livestock operations. What does very high mean? On a soil test, in agronomy, it means that there's no P needed to grow a crop. Does very high equal high environmental risk? Maybe, but not necessarily. Very high soil P, but low runoff and erosion potential could be low P loss. On the other hand, low soil P doesn't necessarily indicate low P loss if we got high soil erosion. So we created the Iowa P Index, and many other states have adopted this phosphorus index now because the DNR does accept it, and most regulators are now accepting it as a very logical thing to do in determining how much phosphorus we can put on our fields. It considers the soil, it considers the landscape, it considers your management practices. It provides a risk rating, an interpretation of that risk. The producers can use that P index to identify causes of high P loss and provide options to reduce that P loss. It has been developed by Iowa State University, the Iowa USD NRCS, USDA National Soil Tilth Lab, and with input from farmers and agribusinesses. It is based on Iowa research and scientific knowledge. There's some bulletins out there related to it if you want to read more about it. Also, by the way, this PowerPoint that you're looking at was developed by the Department of Natural Resources at their website. I modified some things in it to fit this class, but I'm using their PowerPoint because it does a very good job explaining this, and it is important to them that we understand where the P index comes from and that we use it to help make better decisions out there. There are three components in the P index. One is erosion, second is what would run off that surface, and third, what would be through the subsurface drainage. The sum of those three components gives us an estimate of the P loss from that field. A P index, three components, as you can see. So erosion, that's what comes off in the particulate attached to the particle. Water runoff is if you're a really high concentration of P, it could actually dissolve into water. It says fixed. Not when you get extremely high, it's not. Then it could dissolve in water. Same thing, it could, in extremely high concentration, dissolve and come out in our tile inlets. The second and third factor are not big. You've got to have some extremely high P for those to even be a factor. It's the number one up there in the left-hand corner, the biggest picture. That's the one that becomes the biggest player as we look at it. P bound to sediment, our soil erosion component. Total gross soil erosion estimate. Now, for the P index to be a true P index to meet the DNR standards, you need to use Russell II. Okay, it is a revised universal soil loss equation. It measures ephemeral erosion, it measures gully erosion to a certain extent, but ephemeral and real erosion are probably our most important. You need to take into account also the sediment trap factor. We're looking at erosion, in other words, what will settle out before it gets to the stream, as well as the sediment delivery factor. A buffer strip factor is taken into account here, as well as the total soil P factor that reaches there, and a sediment enrich factor. All this is going to be put together in a formula. We don't need to do a lot of work ourselves. We're going to work through the spreadsheet here as an assignment, and you're going to need to do the spreadsheet for your own farm operation, your crop management plan. It all comes together fairly easily. It sounds complicated, but it all does come together. What is the erosion component? It's the amount of soil that actually reaches the stream in tons per acre times the concentration of phosphorus in that soil. That's going to give you the P reaching that stream. That's very simple. Russell II, like I said, is the official one there. Your local NRCS office can run the Russell II for you. They work with it every day. They know how to use the formula. They're trained in it. If you want, it's a free download. And you can go to that web link there and download Russell II. I believe that web link is still active. And download that software and use it yourself. I've worked with it a little bit. I think it's too complicated to work with. I don't want to take time in this class to work through and train you in the Russell II. As long as you can go in the NRCS office and let them work with it, feel free to have, when you're doing a real manure management plan, have them do the work. What we're going to do in this class is use WEPP. This is something put together by Purdue. It's a water erosion prediction project they put together. It will give us a close estimate. It's not as good as Russell 2, but it does give us some numbers and show us what our soil erosion is. You do have an assignment with this. I'm going to pause this. I'll go to the WEPP website there and just kind of walk you through how it works. Okay, you can go ahead and open up the assignment for WEPP and look at that. It gives you a scenario that you have to walk through and look at. We're just going to walk through whatever I make up right now, whether it matches your worksheet or not, I don't know. But we're going to go to the WEPP web interface and do the WEPP model. And I just used the basic hill shade slope profile as we work with that, and it should take you to this page if it doesn't take you automatically there. The state we're in is going to be Iowa. Climate station, I'm going to find something that's close to us here, and I think I actually tell you which one to use. There is a Decorah dry run. We'll use that climate station. Field length, field width, slope shape. You can look at whatever you want there. If you want to view what it's going to look like, that's what that would. More typically, we're probably in an S-shaped slope where it's kind of flat, steepens up, and then sloughs at the bottom. You can need to pick a soil. I believe we're on a Downs or Fayette in the worksheet. I don't remember which, but I'll go ahead and scroll down here. We'll go to the Downs Silt Loam for that. Management, what kind of crop are you working with? I guess on my screen I'm going to have to go across here so I can just see that. We're going to pick some type of corn. That's not going to fit on my screen, it looks like. Well, we'll just use barley, but you can change that to whatever crop. And whatever number of years you want to run, I'm going to run in a 5-year here, and then I'm going to calculate my soil loss. It'll run it and come right here, and it says my precipitation, my area is 29 inches of rain. About 2.9 of that's going to run off. And under this situation, with only a 100-foot length of slope, I'm only using a half ton per acre with a 5% slope. You can get some graphics down below here if you scroll on down. Also, to show you a little more about this and how it works, there's your slope, there's where your erosion occurs, and actually down at the bottom, you actually, why it goes down, it means you're actually accumulating soil down there as you look at that. So that's the WEPP. Hope you enjoy the worksheet and get a chance to practice with a scenario with your worksheet. And I'll stop and let you do your assignment now.